The way the book organizes things, I think, is a little bit off. It makes more sense to me for you to learn about right triangle trig before you get into trig functions on the unit circle, because you already know something about right triangle trig. You may remember from a previous course the mnemonic SOHCAHTOA, which reminds you that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. The other three trig functions are reciprocals of those. Cosecant is the reciprocal of sine, so it's hypotenuse over opposite. Secant is the reciprocal of cosine, so it's hypotenuse over adjacent. And tangent or cotangent is the reciprocal of tangent, so it is adjacent over opposite. So if you're given a triangle and you're given the sides of that triangle, let's say this is a 3, 4, 5 triangle, and this is our angle, you can immediately say what each of those trig functions are. Sine of theta is opposite over hypotenuse, that's 3/5. Cosine theta is adjacent over hypotenuse, so that's 4/5. Tangent is opposite over adjacent, so that's 3/4. The other three are just reciprocals of those. Cosecant is the reciprocal of sine, which is 5/3. Secant is the reciprocal of cosine, so it's 5/4. And cotangent is the reciprocal of tangent, so that's 4/3. We can also use this idea to find trig functions of some angles that we know some things about. If we have a 30, 60, 90 triangle, you've learned in the past what the ratios of those sides are. The side opposite the 30 degrees is x, the side opposite the 60 is x√3, and then the hypotenuse is 2x. So it follows that the sine of 30 then is just opposite over hypotenuse, x over 2x, which is 1/2. Cosine 30 degrees is adjacent over hypotenuse, which is x√3 over 2x, or just √3 over 2. Tangent is opposite over adjacent, which is x over x√3, so 1/√3. And remember, we need to rationalize our denominators, so that comes out to √3/3. And then the other trig functions are reciprocals of those. Cosecant of 30 is the reciprocal of sine of 30, so that's 2. Secant of 30 degrees is the reciprocal of cosine, which rationalizes to 2√3/3. And the cotangent of 30 degrees is the reciprocal of tangent, which is just √3. And we could similarly figure out the trig functions of 45 degrees because we also know the ratios for a 45, 45, 90 triangle. The sides opposite the 45 degrees are equal, and the hypotenuse is those times √2. There are a few identities that we can use to relate trigonometric functions to one another. There are two that are called quotient identities. The first is that the tangent of an angle is equal to the sine over the cosine. Right? Sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So if you look at that, the hypotenuses cancel out, and you're left with just opposite over adjacent, which is tangent. So that one works out. And then the opposite, or the reciprocal is also true. The cotangent of theta is equal to the cosine over the sine. Right? Pythagorean identities are also useful, and they're called that because they're related to Pythagorean theorem. But the first one is that the sine squared plus cosine squared equals 1. Now sine squared, what this actually means is you take the sine and then square that value. But if you put the squared at the end, then it would look like you were squaring theta, and that's not what you want to do. So that's why it is written in this way. Sine squared theta plus cosine squared theta equals 1. And that's called a Pythagorean identity. If we plug in our opposites and hypotenuses, sine squared would be opposite squared over hypotenuse squared. Cosine squared is adjacent squared over hypotenuse squared. And opposite squared over adjacent squared is equal to hypotenuse squared, based on our Pythagorean theorem. So that's why it's called a Pythagorean identity. Our second Pythagorean identity we can find just by dividing through by cosine squared of theta. If we divide each of these terms by cosine squared, sine over cosine is tangent, so sine squared over cosine squared is tangent squared. Cosine squared divided by cosine squared is 1, and 1 over cosine squared is secant squared, because secant is the reciprocal of cosine. In like manner, we can get our third identity by dividing each of these terms by sine squared. Sine squared divided by sine squared is 1. Cosine squared divided by sine squared is cotangent squared, according to our quotient identity. And 1 over sine squared is cosecant squared. So these 5 trigonometric identities can let us figure out, number one, figure out other trig functions when we know some of them. And we can also use them algebraically to help us simplify expressions. So for example, if I give you that sine of theta equals 3/4, we can figure out the rest of the trig functions of that angle without ever knowing what the angle is. If we plug this in to our Pythagorean identity, we can then figure out what cosine is. Sine is 3/4, so sine squared, 3/4 squared plus cosine squared theta equals 1. 3/4 squared is 9 over 16. If we take 1 minus 9 over 16, then we get that cosine squared is 7 over 16. And taking a square root gives us that the cosine is root 7 over 4. So now we have 2 of our trig functions. We can then figure out what tangent is using our quotient identity. Tangent of theta is sine over cosine. And we can plug in those values. We know that sine is 3/4. We know that cosine is root 7 over 4. So our 4's cancel out, and we're left with 3 over root 7, which rationalizes to 3 root 7 over 7. And then we can find our other 3 trig functions just by taking reciprocals. Sine of theta is 3/4, which means that cosecant is 4/3. Cosine of theta is root 7 over 4, which tells us that secant of theta is 4 over root 7, which rationalizes to 4 root 7 over 7. And if tangent is 3 root 7 over 7, that means that cotangent is just root 7 over 3. So anytime you're given a trigonometric function of an angle, you can follow this pattern to figure out the other 5. You can use a Pythagorean identity first, then maybe take reciprocals if you need to, and then apply one of our quotient identities to get the last pair. We can also use our trigonometric identities algebraically to kind of simplify expressions. So remember, we have our 3 Pythagorean identities, we have our 2 quotient identities. I didn't write them up here, but we also have our reciprocal identities. Cosecant is the reciprocal of sine, and vice versa, and cosine and secant are reciprocals in tangent and cotangent. So if we have something like this, we've got tangent theta times cosine theta, we can use our identities to simplify it. Now, whenever you see something that has tangent or cotangent and sines and cosines, it's almost always a good idea to plug in sines and cosines for the tangent or cotangent. Tangent theta is equal to sine over cosine. So we can plug in sine theta over cosine theta. And here we can see a cosine theta cancels out. So this expression simplifies to just sine of theta. Down here, whenever you see something squared, that's probably a good clue that you're going to want to use a trigonometric identity. Here we have 1 minus sine squared theta, which isn't quite any of these identities. However, if we take this and move it to the other side, we can see that 1 minus sine squared theta is equal to cosine squared theta. Secant theta is the reciprocal of cosine, So we can plug in 1 over cosine theta, and then a factor of cosine theta cancels out, and this simplifies to cosine theta. So those are a couple little guidelines. If you see tangent or cotangent combined with sines and cosines, you probably want to turn the tangent or cotangent into sines and cosines. Anytime you see a trig function squared, it's a good bet you're going to want to use a Pythagorean identity. But there isn't really a formula for how to do every one of these problems. You have to apply some creativity, maybe do some trial and error to see what substitutions you can make that help you simplify an expression.